So, very good evening to all. I'm audible to you. So, very good evening to all. I'm audible to you. Can anyone put S in chat box if my voice is clear? Is my voice is clear? So, good evening, Ganesh, Shreyas, Siddharth. Good evening, Bharat Kumar. Good evening. Yeah, thank you for your response. Okay, thank you for your response. So, today is the first day of our master class, Advanced VLSI Design and Verification. So, how many people are ready? So is my face is visible for you? It's clear. Is my voice is clear? Is my face is visible for you? Can anyone respond in chat box? Yeah. So I think we can start now. Is my voice is clear? My face is also visible for you. So I'll change my position right now. Just a minute. Sorry for this. So today is our first day for advanced VLSI design and verification. So in this master class we will see a lot of things. We will see the verification of chip design. So may I know this? What is the name of this? It is visible for you. What I'm having in my hand. Can anyone respond in chat box? What is this? You can guess. Can anyone respond please? What is this I have in my hand? So this is a thing VLS engineer they are made. So the chip was made by VLS engineer only. So there are many engineers are work together to make one chip. So like a front-end engineer, back-end engineer, like IT itself we are having the front-end and back-end. Yeah, correct. IC chip, microprocessor, microcontroller, SOC. So we are telling correct answer only. Like Sumit, Bharat Kumar. Yeah, you are correct. Okay, super. So thank you for your response. So in this master class, we will see how these chip are made. So what are the engineers they are involving to make one chip. So what is the process of, what is the design flow of chip making. So we will see in the one by one, we will see in this session one by one. So what are the engineers roles they are involving, like what are the front end engineer will do, what are the jobs are done by back end engineers. So for chip making, we need two engineers, like a front-end engineer, back-end engineer. Okay. So before going to start, I will explain what are the things we will learn in the 30-day of master class. Okay. Sorry for that. It's visible for you my face. I changed my green mat. So I think it looks like correct on itself. Okay, so we'll start the session. So we are gonna see the what are the design rules and the verification rules, how to follow the chip, how to follow the making the chip like this. So firstly, before going to that, I will give the brief intro about Pantech. Okay, so we are the Pantech. So we have the 20 years experience in education department. Already we trained about 10 million students regarding their career or education project work, lot of things. And also we are doing the lab equipments like DSP kits, FEJ kits, and then lot of things we have doing with my Pantech. So these are the brief intro about Pantech, and then these are our associates like DOT Karnataka, DOT Telangana, Tamil Nadu Skill Development Commission, and then NM also. We have the commitment. We have the tie-up with NATK, NATTR, and then we have commitment with IETE and then IIPL. So these are our associates. We are working together. And then before going to that, I will show you some interesting thing about Pantech. So what are we done? So let's just change the slide. So just a minute. So this is our LMS site. So in this site you can get a lot of informations. So if you want to learn EV, if you want to learn data science, AI, machine learning, deep learning, so which domain do you want to learn, you can start with Pantech. So we are having a lot of supports like autonomous vehicles, EV design, renewable energy, BMS for EV electric vehicle. So for the coding side, program side, we are having all the domains like Python, Java, Flask, lot of things. And also we are having the bundles. So and then we are having the FEJ courses, FEJ, and then VLSI courses, embedded courses. So if you want to learn any regarding this careers, you can start with Pantech by purchasing this. So you have a lot of things like as internship on VLSI, OpenCV, MATLAB, lot of things we have in LMS of pantechelearning. You can check it, and then if you want to interested means you can buy in the LMS site. And I will show you another thing like a LinkedIn page of our pantechelearning. So this is our LinkedIn page. So we will daily post some interesting things about learnings, like what are the course we will provide. So what are we are posting continuous learning things about all the kind of domains like embedded, VLSI, IT related domains, lot of things. So if you follow this, you will get a lot of information from Pantech site. And also you can subscribe our Pantechelearning YouTube channel. You will get the free classes, free master classes. Based on this, you can learn a lot of things from Pantechelearning. So this is our Pantech brief intro. So let's get into session. So I will show the agenda of this 30-day masterclass. Okay, just a minute. Okay, so this is our 30 days plan. So each and every day we will do some interesting things. So in first day we will go to the introduction about VLSI. So like this, how chips are made, we will see this in this today's session. What is the difference between backend and frontend? So what are the roles and responsibilities for front-end engineer, backend engineer? We will see in this session. And then tomorrow we will see the computer architecture. So computer architecture is it's not like a easy thing. So it is a backbone of our computers. So it having some architectures like a RISC and CISC, lot of ARM architecture, lot of things is there. So we will see the tomorrow session. And then we will see the third day of digital electronics. So this is a basic thing. So digital electronics is a basic thing for VLSI. So first of all, we have to learn the digital electronics like circuits, combinational circuits, sequential circuits. These are the basic things we have to learn for VLSI engineer. So we will see in the third and fourth day of our master class. And then FSM. So FSM is one technique, writing the RTL code. And then we'll see the 6-day timing concept, like a clock related things, like a setup time, hold time. This all comes under the clock related things. And then 7th day we will see the overview of Verilog. So Verilog is like a basic coding language for VLSI design engineer. We will also see in this session of day 7. And then in the second week we will get into verification domain. So verification means we have designed the we can design the RTL, we can design the chip, but we have to verify by code itself. So for that we need some languages like a SystemVerilog. So we will start from SystemVerilog basics. It is used for verification of chip making. Okay. So in the 8th day we will start from SystemVerilog basics like a data types, operators, and then always block kind of thing. And then in the 9th day we will start the OOPS concept. So it having some SystemVerilog having OOPS concept, we will see in the day 9. And then the 10th day of our masterclass we will see the mailbox, queue, even, semaphore in SystemVerilog. So these are the major things, the major topics you must learn for verification in SystemVerilog. And then in the 11th day, 10th day, 12th day, we will see the SystemVerilog assertions, and then test bench architecture, and etc. So in the 13th day, we will see the immediate and concurrent assertions. So assertion is one of the technique in SystemVerilog to verify the design code. So let's see one by one. So if I tell these all the assertion, test bench architecture of SystemVerilog is a big topic, you can't be able to understand if you are beginner of this SystemVerilog. And then we will see the one mini project or the 14th day UART protocol. So UART one protocol, it's like off-chip protocol, it having transmit and receiver. So we will see the test bench code for UART protocol in the day 14. Okay, so these are the our first 2 weeks activities, the first week and second week. So let's see the week 3 and week 4. Okay, so in the third week we will see the advanced RTL design and verification related things. So advanced means we will see the some more important topics like a FIFO memory design, a RAM and ROM, and then clock domain crashing, constraints. So these are the huge topic in verification part. Okay, and then in the 19th day we will see the protocol like I2C, and then I2C design code and verification code. So these are our third week of our third week contents, third week learnings. Okay, in the fourth week we will see the lot of topics like AMBA protocols. So AMBA protocols, coming to AMBA protocol means, so if you have aware of the SoC, system on chip, if you know the system on chip, the AMBA protocols are mainly used on the SoC. So SoC means nothing but it's like our mobile processor. So we having the mobile. So in the mobile we having the chip, like that chip is called SoC. SoC means system on chip. So it having a lot of blocks like it having a CPU core, GPU core, memory block, and then counters, registers, having lot of blocks. So for communicating from one block to another block inside the single chip, the AMBA protocols are mainly used. So like AXI, APP, AHP. So these are the main protocol, high speed protocols industry are using inside the chip. So we will see the these things in my fourth week of masterclass. Okay, so these are the very huge topics, huge protocols. All these like APP, AHP, AXI, all these protocols are used for SoC only. Okay, SoC and high speed communication kind of thing inside the chip. Okay, these AMBA protocols are called on chip protocols. So on chip means inside the chip it having some lot of blocks. So for communicating from one block to another block we have to use these protocols. Without these protocols you can't make good communication between the blocks. Okay, so till now do you guys any doubt, you can ask in chat box. So certificate will provide. So if you till now do you guys any doubt from this agenda? So okay, happy evening. So good evening Malarmadi ji. So let's get into next intro of advanced VLSI design and verification. So I already asked one question. So what is this means? You are telling like this is a chip, integrated circuit, ICs, correct. So for this making this chip we need two engineers. One is front-end engineer, another one is back-end engineer. Okay, so front-end engineer will do the software part of the chip making. So for making the chip, to make the one chip, we need two engineers. One is front end, another one is a back end. So front end engineer, they will do the design and verification part of chip making, and then back end engineer will do the physical things, so like a physical activities to making the physical chip and then building the number of transistor in the chip. So these all things comes under the back end engineer. So this is the two major roles are involving to making one chip. Okay, till now, do you have any doubts for making this chip? So in this session we will see the difference between the front end and back end. So what are the jobs are done by front end engineer, so what are the jobs will done by the back end engineers, and then we will see the design flow of chip making. So where we'll start, so where we'll go, so what is our first step, so what is our last step, so what are the things comes under the front end engineer, so what are the things comes under the back end engineer, we'll see in this session. This is an intro session for chip making. Okay, so and then so this is a difference we'll see in this session, front end back end, RTL versus verification. So RTL is nothing but writing the Verilog or SystemVerilog design code for some chips, like if you are making the chip like I2C model chip, so I2C SPA chip, so you are writing the I2C protocol design code, means you are the design engineer. So if you verify the design code, means you are the verification engineer. So this is a difference between design and verification. So design writing in the design code is called RTL code, register transfer level code. Okay, register transfer level code is called design code. So let's see what is the main difference one by one. So these are the things we will learn. I already said no. Explore the applications of VLSI, and then difference between the front end and back end, and then RTL design and the verification design difference. We'll see one by one. So before going to that, I want to ask one thing. So what is VLSI? So what VLSI engineers will do? So what is the VLSI evaluation? So VLSI is a very important thing for AI current scenario. Not only for current scenario, VLSI is very important thing. Okay. So can you respond in chat box what is the VLSI? So I need some response from your side. So based on that one. So can anyone respond in chat box what is VLSI? So what is the VLSI engineers will do? What are the work they will make? Can anyone respond in chat box what is VLSI? So if you want to mark the present attendance, means you have to wait for some time. So our coordinator will post the attendance link in chat box, and then you will fill the attendance link. So designing, chip designing and manufacturing. Okay, chip designing and manufacturing is a basic thing. So what they are building, so what they are doing inside the chip. So so in this chip, what we are having inside the chip. So what is the consist of this chip? So may you know that particular device name? Can I guess some in chat box? Actually, what is inside the chip? Many components, single microchip. So VLSI means very large scale integration. So that's fine. So I want to know sharply what is inside the chip. So what electronic device are inside the chip? So I'm getting some response. Yeah, gates, transistors, correct. So transistor is the correct answer. So we are building the n number of chip inside the transistor, so inside the one chip. Okay, we are building the transistor inside the chip is called. This is a work done by the VLSI engineer. So our main focus is we have to build n number of transistor inside the single chip. So chip means like a one framework kind of thing. So by inside the chip we are building the transistor. Based on this transistor only, we are making some circuit, we are using some we are making as a processor, we are making as a controller, we are making as a SOC, FPGA, lot of things. So in transistor correct answer, we are building inside the chip. So this is a definition for VLSI. So processing of creating integrated circuit by combining millions to billions of transistor onto a single chip. So this is a VLSI work. Okay. So and then I have another question for you. Some interesting question itself. So till now we are achieved 5.3 trillion transistor we are builded in the single chip. So currently we are achieved 5.3 trillion transistors. It's not like just a simple count. It's a 5.3 trillion. It means I think 5 crore 5.3 5 lakh kind of thing. So 5 lakh crore transistor we are built in the single chip. That's why we are using the AI, like autonomous vehicle, EV vehicle, autonomous robot. We are using this. We are using fast computing things based on the chip only. So if if didn't have a lot of transistor means we are based on the we are work like a slow only. By because of, if you want to increase your computer speed of, if you want to increase execution speed or processing speed of your computer means we need the high speed chip. So based on the high speed chip only we can attain the high speed execution of our computer. Okay, so high speed means what? How VLS engineer will get the high speed? It is based on the transistor count only. If the particular chip it having the high number of count of transistor means it will work fast. How it will work fast means it having a lot of transistor, it can do easily execute lot of complex instructions, so it will work fast. So main thing is the main three things is we have to follow as a VLS engineer. First thing is we have to make the chip. That chip must be high speed, low power consumption, and then small in size. So these are the main things. First thing is we have to make the chip based on it. It must be the small in size, power consumption must be very low, and then speed of the chip. It must be execute. It must be perform high speed. So these are the main things. Three main things we have to follow the VLS engineer. Whether like you are a front end engineer, you are the back end engineer, you have to follow these three main rules. So we are making the chip every year. So we are getting some improvement upgrade from the chip. Like for example, if you taken like Intel i-Core 7, i7, difference between i7 and i5. So i5 will execute instruction very slowly compared to the i7. So these transitions are made by the VLS engineer. Okay, so till now, do you have any doubt? What is the main role of VLS engineer? One is we have to reduce the size, and then we have to increase the efficiency like a speed, and then we have to reduce the power consumption. So why we have to reduce the power consumption means if your chip consuming the more power means we have to give the more power. For that we need to give some direct supplies. We can't use the battery means our mobile phone battery kind of things. So if you having the battery power means we can reduce the hardware size. Okay, till now do you guys understand? Are you getting my points? Yeah, i7 is a new version, but comparatively i5 with i7 means i5 is a very low speed, i7 is high speed. Okay, this evolution is based on the VLS engineer only. Okay, so and then density, speed versus size. Yeah, correct answer from Chakravarti SR. You are telling correctly. Okay, so let's get into another difference between the front end and the back end. So why we need to reduce the size? So why we need to reduce the size of hardware means, for example, if you are living in 80s or 70s or 60s, if you are using computer, you must need the whole room to make one computer. But now we are connecting each other by small devices like a mobile phone, tablet, laptop, small things. So we are reducing the hardware size gradually. So from starting stages it will take whole room for one computer, but we can I can do the computing operation in my hand itself. It is very compatible with my hand. This evolution is based on the VLSI only. That's why we need VLSI. That's why we have to reduce the hardware size, and that's why we have to reduce the chip size also. So if you are using chip size like this, it's like this means we have to make the hardware size very big. So it's look like a big in size. It is not like a compatible, so you can't take it over any of your places. So it is not a portable to all the locations. So for that reason we have to reduce the size, we have to increase the efficiency of chip, and then power consumption must be low. Okay, so I think your doubt is clear now, why we are reducing the hardware size, chip size. So and then we'll move to the design flow. Sorry guys, it's visible for you, design flow. So these are the stages, like you can see now. These are the stages are involving to make one chip. Okay. So for example, there are two parts. This part is comes under the front end engineer, and then this part is comes under the back end engineer. So I will show you one by one what are the stages for front end engineer, what are the stages for back end engineer. I think it's visible for you, or else I will zoom it. So I think it's visible for you. Okay. So it's coming to the front end engineer. So I already said no. Front end engineer will do the design and verification part of chip. For example, if you are making one chip, you have to write the RTL code, design code, and then firstly we have to write the logic of chip, like a working of chip in the HDL language. So HDL language means nothing but hardware description language. Okay, you have to write the description HDL code, and then you have to verify that. After that only you can move into chip making, like a fabrication part. Why we need to design and verify means, without verification we can't assure that it will work correctly or not. Why? Because of, for example, if you are making the one chip, it is used for a car, like for example, if you take like a car as example, it having the airbags. Okay, all the car having the airbags. Nowadays cars comes with the airbags only for the safety purpose. So for that airbags, that particular airbag works based on the chip controller. So one chip it is used for airbag controllers. The input for chip is one sensor. If the sensor is on, means it will on the airbag, like it will give the air for the airbag, and then it will open, it will save your life. So if any changes, if any delay is there, like my sensor is on, and then but there is a delay between the chip and sensor. There's a delay between the getting input from sensor in the chip. If the delay, it will cause huge damage. Why? Because of, if the car crashed, or if the car meet an accident, means at the same time it will airbag must be open. If it is not opening, means a human will death, or any dangers will happen. So if there is any delay, means you can't like if there is a delay, means the huge problem will come. Why? Because of it's like a natural accident. It's not like a natural thing. So we are using one chip, the chip is malfunctioned. So malfunctioning means there is a problem in chip. So we have to make a chip without bugs, without problem. So we have to clarify that first. Why? Because of, if you made one chip with a problem, with a bug, with a delay, means it will cause many human loss, or any energy loss, anything. It will cause many losses. Why? Because of everywhere we are using chips, like a car, industries, mobile phones, all the electronic department we are using the chips. If you make one chip with the bugs and the issues, means it will cause money loss, human loss, lot of things it will cause. So if you want to rectify, means you have to make chip with working correctly. So for that we have to design the correct logic, and then we have to verify the code itself. Then only we can move into the chip making, physical chip. If you make a chip with the bug, means we have to remake the chip. So you can't change the chip functionalities. If you made this chip once, means you can't recreate the logic inside the chip. Okay, you can't create the you can't do any changes after the chip making. If you want to change, means you have to start from beginning. So you have to start from a new chip. Okay, that's why we have to verify the chip code, or verification, and then design code, very important. So main thing is we have to focus on front end engineer. So front end engineer is a very important role for chip making. So they must be ensure that it will working or not. After that only back end engineer will do the chip manufacturing. Okay, if I made this chip with bugs and some issues is there, totally it is waste of money, time waste, money waste, all the things are waste. What I given for the chip making, totally waste. We have to start from beginning. For that reason, we have to design and verification is very important. So let's see what are the stages. In this front end domain, firstly we having the system specification. So system specification means we have to we have to make one specific, like a spec means if you're using the chip for computer, or if your chip for microcontroller, if you are using that chip for IAC, so we have to we have to write the spec. So what are the things it needs? So how many transistor, how many IO pins, and then how many clock pulses it need. So what is the clock frequency? This all comes under the specification. So we have to we have to decide what are the requirements for the chip. So this comes under the system specification. And then architectural design. So design means, so I already said no, our processor like i7, i5, and then SoC, it having some architecture. So architecture like a CISC and RISC. So we will see the next question, what is the architecture of chip making. So it's like a pipeline instructions. So CISC is called one architecture we are using nowadays for processor. So mostly our Intel i7, i5 processor use the CISC type architecture. CISC type means complex instruction set computer. So RISC means reduced instruction set computer. So this is one architecture we have to follow, make the one chip. So this is a second stage of our front-end engineer role. And then functional or behavioral design. So this is our main role of writing the Verilog code or SystemVerilog code. So if you are making one chip for particular logic means you have to write the HDL code for the chip, like if you are writing the AC controller condition means, if you are writing the i7 architecture code, i7 processor, you have to write the Verilog code for your design. So this design writings comes under the third stage, functional or behavioral design. And then in the RTL, so in the RTL design means we have to design the FSM. So FSM means I will tell you one by one in my upcoming classes. FSM means finite state machines. So we have to write the FSM for my design. So this all we can write by the Verilog code, SystemVerilog code. This is my third stage. So we have to write the logic in functional and behavioral stage, and then we have to again write the RTL code for my logic using the FSM, based on the FSM logic. And then here we are having the functional verification and testing. So testing and the functional verification means, so we have to write the test bench for the design. So design engineer will write the design code. We have to verify the design code are working correctly or not. So for that reason we can write the SystemVerilog architecture test bench code to give the input for design code, and then we will check the results, it will working correctly or not. This process comes under the functional verification and testing. So the particular design engineer will write the Verilog code for logic. We will write the Verilog code for required logic, and then after that stage we having the verification team. So there is a verification team. We'll write the test bench. Test bench is nothing but writing the stimulus for design code. Okay, writing stimulus for design code. They will do some. They will follow some architecture like a SystemVerilog architecture and also UVM architecture. So these two architecture for the verifying the design code. Okay, these stages comes under the functional verification and testing. They will do the direct simulation test, constraint random test. So these are the things we will see in this session. We are mostly use this functional verification testing part in this 30-day masterclass. So we will see also design code, and then we are mostly focusing on verification part in this 30-day masterclass. Why? Because of we are gonna use SystemVerilog language for writing the design code and also writing the test bench code. Okay, we are gonna see in this masterclass based from this stage itself. Okay, functional verification testing, and then logic synthesis. So it is nothing but converting the design code, like your logic, what you are written in Verilog. We are converting that logic into logic gate circuits, like in converting the Verilog code into gate circuit. Why? Because of we can't directly implement the logic inside the chip. So we have to convert the Verilog code into gates. That part will comes under the logic synthesis. It will do one engineer. So this is also comes under the front-end engineer. And then after the stage we having the gate level netlist. So gate level netlist is nothing but, so we having the already said no, we are converting the Verilog code into gates. So in the gates we having the input and output pins, and then number of gates we are using. Gates is nothing but normal logic gate, AND gate, OR gate, XOR, NAND and NOR. Based on these gates, we have to make the circuit based on the your design code. Okay. So in the stage of gate level netlist, they are converting, and then they are converting the Verilog code into gates, and then they will do the number of gates. So number of gates it having. So and then number of interconnection. So interconnection is nothing but wire. Okay. This process comes under the stage of gate level netlist, and then logical verification. So logical verification is nothing but after the gate level netlist. So after the making the gate level netlist, they will do one verification, again verification. So you can see now, firstly you can see now verification is very important. Why? Because of here we are designing, we are writing the RTL code, and here we are writing the FSM and the Verilog code for our design. Again we are testing by the verification language SystemVerilog and UVM, and we will do the logic synthesis. Again we will do the gate level netlist. Again we will do the verification. If any bugs are there in this stage, again we will go to the RTL part. RTL part means design code part. We have to rectify the error, and then we will make the functional verification. Again we will make the logic synthesis. Again we will make the gate level netlist. Again we have to verify. After this verification only, if it is working correctly, means they will proceed to backend engineer. So in the backend engineer department, it having a lot of domains, a lot of stages. Like if you are seeing this, like system specification, architecture design, functional verification, RTL code, functional verification testing, logic synthesis, these all not like a stages. These are the engineers. So each and every stages having a engineering domain. So these are the domains we having the design front-end engineer in VLSI. So it having a lot of job opportunities. Like if you are design engineer, means you will write the only design code. If you are a design verification engineer, means you will do the verification also, design part also. Why there is a domain called design verification, means we can't verify without knowing the design. So for that reason we have to know the design, and then also you must know the verification related things. So for that reason we need design verification engineer. And then logic verification. So here we'll having some engineers work. So these are the front end roles and responsibilities. So coming to the back end, they will do the physical activities of chip. Okay, they will do the floor planning, they will do the placements. So placement is nothing but they are telling like, so where we having the, so the I already said no, SoC it having a lot of blocks, CPU cores, GPU cores, RAM, like a memory, direct memory access registers. They are in the single chip, it having a lot of blocks. In the placement, they are choosing, they are telling like how many transistors for this block, so how many clock pulses, how many clock frequency needed for this particular block. So these all things they are done by the physical design engineer. They will do the partitioning, floor planning, placement. Placement means nothing but making the transistor in the corresponding blocks of chip. Okay, and then clock tree synthesis. So clock tree synthesis is nothing but, so for example, if you take in one chip, like if you take in your mobile chip SoC, it having a lot of blocks, like it having CPU, GPU, memory block, and then lot of peripheral block. Each and every block works based on the different frequency of clock. Okay, so different frequency of clock means we have to separate that. We having only one input for clock, we have to divide the clock, we have to increase the clock frequency, we have to decrease the clock frequency to respect to the block. Why? Because of each and every block works based on the own clock frequency. So we need to give, okay, for that they will do that kind of clock related things inside in the stage of clock tree synthesis. Okay, and then signal routing, and then timing closure. So these all things comes under the backend engineer. So and then comes under the physical layout. So physical layout is a final layout. It's like they will do one file like a .def .spf file after the physical layout file. So based on this file like a gdsii .spf file, these are the files will made by the physical design engineer. After that they will given to the fabrication. Fabrication is nothing but by using the laser treatment they are building the transistor. They are building the physical transistor inside the chip. Okay, it means inside the chip it having lot of arrays, like a layer by layer it having transistor. Each and every transistor connected by the wire means not like a physical wire, it having the copper wire. It's like in very small in size, like a nanometer kind of things. So we achieved like a 3 nanometer chip design. So it means each and every wire having the 3 nanometer of size, like a length. Okay, so these things are made by the industries fabrication units. So they will make the physical chip based on the report given by the physical design engineer. They will give the file like a dot spf, dot def, gdsii. These files, based on these files only the industry will make the physical chip. After that they will do testing again. So after making of the physical chip they will do the testing again. If the chip is passed, if the chip is fast means they will give for mass fabrication, and then they will even for public use. If it is fails means again they will do from starting. They will do working based from the functional design and verification. Okay, that's why we are using chip very accurately, correctly nowadays. We are spending most of times in verification of chip. Okay, if you taken like a chip making, most of time we are spending in verification only, not a design part. So design part is it's not like a simple thing, but in design part there is no need to give more time. So for verification is we have to give more time. Why? Because of if any bugs means they will give the huge losses. So we have to make the chip without bugs. This is our third or fourth goal of VLSI engineer. Okay, till now do you guys understand? Do you have any doubts? So let's get into another slide. So three design domains, like a design domain, behavioral domain, structural domain, physical domain. So these are the three domains. Let's see one by one. So in the behavioral domain they will write the system. They will start from system and then they will write the algorithm. So algorithm is like not like a it's like a FSM. So and then they will write the Verilog code, RTL code, and then they will converting the RTL code into gate level netlist. So we already seen in this flow diagram. So that's why I am given in these slides. I divide into three domains: behavioral, structural, physical. If you want to divide this design flow means you can divide by three domains: behavioral, structural, and then physical. So behavioral means writing RTL code. Structural means testing the testing the gate level code. So like a gate level netlist. So we'll see one by one. So behavioral means writing from the algorithm you have to write the Verilog design code. It's like a RTL code. And then after the next domain is structural domain. They will do process of converting Verilog design code into gate level netlist. It's also one gate level netlist also one very kind of Verilog code. That particular code having only input and output of gates. Okay, they will convert the Verilog code logic into gate level circuit, it having the input and output and wires. So this is our second domain, structural domain. And then third domain comes under the physical domain. Physical engineers, they will do the transistor layout, they will make the physical chips, they will check the power supply, power consumption, transistor count, kind of things. So these are the main three domains of chip making. So and then we'll move to the difference between the front end and back end. So we already see in this design flow. So what are the main difference, what are the main roles of front end and back end? If you guys understand this means you can easily understand this difference, front end and back end engineers domains. So front end and back end engineers, we'll see one by one. So they will do the system architecture definition by front end engineer, and then they will write the RTL Verilog code, and then they will do the functional verification using SystemVerilog language and also UM framework. So UM framework is one kind of architecture to verify the design code. It is easy only. So I will tell you difference between UVM and SystemVerilog, and then Verilog and SystemVerilog in upcoming sessions. And then they will do the logic synthesis and optimization, and then they will do the DFT, design for test. So these are all the main roles and responsibilities of front-end engineer. Okay, so and then they are using the tools like a model sim, VCS, Costa sim, design compiler. We are going to use this Costa sim tool, mentor graphics Costa sim tool. We are going to use this tool for this masterclass. So in this tool, from the Costa sim tool, you can write the design code, and then you can write the SystemVerilog code, and then you can write the UVM code, and then you can also simulate the SystemVerilog test bench and also UVM test bench also. So we are going to use this Costa sim tool for this masterclass. Okay. So and then coming to the backend engineer, they will do the floor planning and chip level placement, and then they will do the clock tree synthesis. Clock tree means inside the chip we need a lot of frequencies. One block will need the 50 megahertz, another block we need the 100 megahertz of clock frequency. So we have to pass the clock. So that things comes under the backend engineer, like a clock tree synthesis and timing optimization, and then place and route implementation, and then physical verification, DRC, and then LVS. So LVS is nothing but they will do the current power consumption of the each block. Okay, and then antenna. So antenna means, so if you have aware of the 5G chip, so in the coming from the 2020 or 20 before 20s, before COVID, we having the 4G only. We having the only 4G phones, but we are having the 5G phones. Means we are alter the chip like a 4G LTE. We are using the previously LTE, but we are using 5G. So we have to optimize the antenna also. We have to optimize the like a transmitting signals, like this comes under the networking part. So we have to improve the speed based on that also. So like how to say, based on the signal transmitting and receiving from one device to another device, it's based on the antenna itself. Okay, so we have to make the chip capable of high speed transmitting by using the antenna. So this all comes under the backend engineer. And then GDS file generation. So GDSII file is only for making the chip fabrication. It is used by the chip factories like industries. You know the TSMC is like one of the huge company, like a big company, Taiwan Semiconductor Manufacturing Corporation. They will do the 70% of the chip. Okay, if you taken like in the world, we are using a lot of chips. So from the chips, they are made by the TSMC only. Okay, so this is the back end roles of VLSI. So and then there is a difference between them, front end and back end, and RTL and verification. So RTL and verification. So RTL design means like writing the design code for chip. Verification means they will check the design code. So writing synthesizable RTL code in Verilog or SystemVerilog, this is responsibilities of design engineer. And then implementing the power performance area, and then they will do the comprehensive design documentation, and then they have to collaborate with the verification engineer. Why? Because of the verification engineer, they didn't know all about design capabilities, design rules and regulations. So for that reason, design engineers will have to collaborate with the verification engineer also. Okay, so in the verification side, we have to write the inputs, like we have to write the stimulus for the design. So we have to write the stimulus for the design means we can write by using the SystemVerilog architecture and then UVM architecture. So these are the roles: creating sophisticated test bench, and then test scenarios. This is a very important thing, like test scenarios. Okay, and then develop verification environment using UVM methodology. So UVM one framework. So I will explain you what is a UVM in upcoming classes. So and then implement coverage driven verification. So these are some important topics in SystemVerilog: coverage, assertion, constraints, I will tell you in one by one in my upcoming classes. And then debug and analyze the functional correctness issues. These all things comes under the verification engineers part. And then ensure the design. We have to, the main thing is, main work of the design and verification engineer means we have to, they must be ensured that our design code is working correctly or not. So this is a very important point for verification engineer. So they must be assured that. Okay. So and then the main thing is, this is the main difference between them. And then I already said, no, verification will take the huge time of chip making. So 20% of effort for design only. Most of the 80% of effort only for verification part of chip making. So verification is a very important thing of chip making. And also coming to the job opportunities, comparatively compared to design engineer, verification having a lot of opportunities. Why? Because of, for one design engineer we need at least three verification engineer. Okay. This is a real thing of industry or industry now they are using. Now they are hiring based on this only. For one design engineer they will hire the 3 verification engineer. Okay. So comparatively, job openings or career side, verification having the higher capabilities, higher opportunities. So we are gonna see mostly the verification part of chip making in this masterclass. So till now, do you guys any doubt? So this is the main difference between the RTL design and verification. And then let's see the modern verification methodologies. So it having some we can write the direct test benches, manual test cases, immediate coverage analysis. So this is the things we are using previously. But if you write, but come after the SystemVerilog advancement, we can write we having some features. So these are the features, like a OOPS concept. Based on the OOPS concept, we can reuse the code. So the main motive of the OOPS concept is we can reuse the code. Based on this, we can reduce the time of writing the code. Okay. And then another advantage is, another feature is, we having the SystemVerilog having the some different data types, like advanced data types in SystemVerilog language comparatively Verilog. And then we having the SVA, SystemVerilog Assertion, for verifying and testing the design code. So these things we'll see in this master class in the upcoming classes. And then interface and mod ports. So these are the main topics in verification by using SystemVerilog. We will see one by one in my 30-day master class. So and then built-in randomization and constraints solving. So these are the main features of SystemVerilog. Okay. So and then if you guys are really interested in this master class, you can convert in this 30-day master class into internship. So let me tell you how you can convert this master class into 1 month internship. So you can from this internship you will get the 30 days recording session, all PPTs, all the 30-day PPTs, and then you can also download the PPTs, and then you will get the source code, and you will getting the access for 3 months. And then you will get the project, like a 4 up to like a 2 mini project or 3 main project. You will get the up to 4 or 5. You will get the main and mini projects from the internship, and then you will get the IETE confirmation letter from the internship, and then you will get the 180 days LMS access. Okay. And then you will get the weekly assignment and task, and then you will get the academic internship report. Okay. And then you will get also highly valued IETE certificate given by IETE. So it is important, very important certificate if you are studying in college. So these are the benefits you will get in the internship. So how you will get the internship means, you can buy this internship at the discounted fee of just 999. By using this registration link, you can register. So if you bought the internship, you will get these 8 benefits from the internship. So and then, so if you guys are really interested, you can buy this internship by using this link, registration link, and also you will get the link from chat box. So and then after the link, after the getting the registration link, you will see this screen here in the domain side. Here in the domain column, you have to choose the advanced VLSI design verification MC. So if you choose another domain means you will get that only. So you have to choose this advanced VLSI design and verification MC uh, internship program. Okay, so this is the process of getting internship from Pantechelearning. So this is today for the class. So we'll see a lot of things, chip making. So what are the design roles, what are the verification, what are the roles of design and verification team, what are the roles of backend and front end engineer will do, and then we seen internship capabilities, and also you will get this certificate. So it's a very sample certificate. You will get the in this internship certificate end of your internship, uh, just 999. So thank you for today class. If you have any doubt means you can ask now. If you have any doubt means you can ask now. So do you guys any doubt from this from today class? So today we are seeing only basic things about chip making. So what are the front end engineer roles and what are the back end engineer roles? So do you have any doubt from today class? So thank you guys, thank you for listening. We'll see tomorrow with the computer architecture.